All right, one more big concept for us to learn before we start doing all of our chemical mass balances. And this concept is called extent of reaction, which is probably new. It's not normally something that we see in Chem 1 and Chem 2. So extent of reaction is a measure of how far the reaction has proceeded from some initial state to some later point in time. So extent of reaction is used to keep track of molar quantities and flows, and it's going to allow you to keep track of moles as a reaction progresses through its natural steps. So we define extent of reaction as this funny looking little e. If you're using your textbook, they use a slightly different looking e that's kind of hard to write. So we're going to use this one in our notes just to make it easy for our handwritten notes. And it's going to be equal to n sub I minus n sub I 0 divided by V sub I. And both of those quantities have units of moles of I. So I is a specific species in this example. So let's talk about what each of these things are. So V sub I is the stoichiometric coefficient of the species I. So we need to balance our reaction first, know what species we're talking about, and then we need to take the coefficient, and that's what's going to go down here in the bottom. E is that extent of reaction, so that's something we either calculate or maybe we know. We'll talk about that in a moment. N sub I is the moles of I, that specific species at some point in time, and N sub I 0 is moles at the initial start time. So we're measuring a change in moles up here in the top. And sometimes this is not always our best way of using extent of reaction. So many times what we do is we rearrange this formula so that we can say we want to find the number of moles at some later time. That's normally going to be a lot more effective for us when we're solving mass and energy balance problems, because normally we want to know the final moles in the system. So we can rearrange that equation to say, well, the final number of moles is equal to n sub I naught plus, and this will be a plus or minus later in the class, and we'll talk about that, V sub I times the extent of reaction. So both forms of these would be great to have on your notes for your final exam. So let's talk about an example of how we use extent of reaction and how we set it up. So let's take, for example, N2 plus 3H2 to generate 2 moles of ammonia, NH3. So let's say that we're going to feed 100 moles per second of N2 and 300 moles per second of H2, and we want to use the extent of reaction to write a system of equations. So when we use extent of reaction, and I'm going to use this form of the equation right here, when we use extent of reaction, we do it on each species separately. So let's take an example of N2. The number of moles that start in the system, and these n's right here, before we go any further, these n's can be n dots, so that's important too. So the initial amount of N2 that we have is 100 moles per second in the system. Now, N2 is a reactant. So in this equation, this plus needs to be a plus or a minus, because a plus will be as if it's generated and a minus will be as if it's consumed. So we are going to consume 1 mole per second of N2 as we go through this reaction, because that's the coefficient, that's the V that goes in here. And then we don't know E, we don't know the extent of reaction. It's hard to measure. But if we simplify this, we get an equation that says 100 minus E, and that's going to represent what's happening for N2. So let's do that for the other two species. For H, we start out with 300 moles per second, and we lose or consume 3 moles per second of H2, and we multiply that by the extent of reaction, so we get another equation that says 300 minus 3E. Then we could do the same thing for NH3. We start out with 0 moles of that, so that makes it easy for us, and we generate 2 moles, that's why there's a plus sign there, times the extent of reaction, so we get 2E. And so what you'll start to see here is you'll start to see we have a system of equations. We have multiple equations that we just wrote. So extent of reaction is going to be kind of like one of those different ways of writing it's like writing a general balance equation in many ways, is we can write a system of equation, right? So that's what our general balance equation allows us to do. So extent of reaction allows us to write a system of equations, but specifically for chemical reactions. So we're going to go over this in lots and lots of detail in class. So make sure that you at least have your equations copied down, you understand how to write this type of system of equations, and then we'll start to apply it as we get into class.